ready to start. So if people who are here for the panel get closer so that we can start the panel. Can you hear me? Oh, I'm sorry, you couldn't hear me. We're ready to start the panel. So, okay. I hope people were able to come in from all the remote locations. Can you hear me? All right. Good evening, everybody. I am super excited about this panel today. I think, sometimes panel have something like, we argue about a specific controversial topic, and sometimes they're panels where we all learn a lot. I think this was designed to be the panel of the second type. So we all know about knowledge graphs. I think we could arguably claim that a lot of ideas, technical ideas behind knowledge graphs actually came out of this research community. And this is sort of seeing them grow up. So we have on the panel technical leads leading knowledge graph efforts in 5 large technology companies. I'll introduce them in a minute. So my hope is that we can have a conversation this evening about sort of what drives the knowledge graph development efforts, what are the differences, how do they make the decisions, where we can help as a research community. Should be interesting. Let me introduce the panelists, and I'm not going to go through all the accolades that many of them have received. You can see all of that in the panel description. I think I'll give just enough of the bio to give you the context of where they're coming from. And I apologize for not listing everything, all of your achievements. All right, so let's see. We'll start with Yu Qing Gao. She leads the knowledge graph and artificial intelligence efforts in Microsoft that underline a lot of products at the company. She has worked at IBM and Apple before Microsoft. She's an IEEE fellow for her work on speech recognition and natural language understanding. Then we have Anand. Actually, did you specifically? No, you didn't sit in exactly the same order. Okay. Anand is an engineering manager at Facebook, where he helps build knowledge platforms to support a range of products at Facebook. So we try to have a different sort of slice of companies and different types of companies here. He worked on a startup, Oslo, to support conversational AI systems previously to that. He has worked at Mozilla. I think all of them will be at the reception as well, so I think there are lots of interesting conversations to be had there. Then is Anshu. Let's see. So works at IBM Watson, where he's responsible for the architecture, for the core knowledge architecture, and language capabilities for IBM Watson, which includes knowledge graph, natural language understanding, and Watson Knowledge Studio. Let's see, Alan Patterson is a distinguished engineer at eBay, heading up eBay's efforts to build a product knowledge graph. Yet another knowledge. So, I mean, all of these are knowledge graphs, but I think they're very different. I think what we will learn today is how different they are. So Alan previously worked on True Knowledge, the startup that was acquired by Amazon that underlies Alexa. We don't have Amazon represented there, but I suspect Alan probably knows what's happening there as well, a little bit of what's happening when True Knowledge was acquired. Finally, Jamie Taylor manages the knowledge graph schema at Google. He joined Google following the acquisition of MetaWeb that developed Freebase, where he was responsible for Freebase. I think we all know Jamie's work. He gave a keynote at this conference last year. Full disclaimer, I work at Google, but I do not work on knowledge graphs, so I will try to be impartial, but I just want to give this disclaimer that I do work for one of these companies. I hope we will have a technical discussion. We specifically sort of made sure that people here are scientists and engineers who can really look at this from the technical point of view. And so without that, so the way this will work is I have asked the panelists to give a 5-minute introduction, sort of describing the knowledge graphs, what knowledge graphs do in their products, kind of give us an overview of what it is about, and then we will open it up for questions. And I'm hoping that most of this hour will be spent with Q&A. So prepare your questions, and you're on first. You have microphones. I don't think you don't have to stand up if you don't want to. And
I cannot sit down. Okay. So, I'm Yu Qing Gao. I would be talking about what are the knowledge systems at IBM. Sorry, I said IBM. Microsoft. You cannot change overnight. You know, I was with IBM Watson for 19 years. It's a long time to change. So actually, we have a number of very large industrial level and enterprise scale knowledge graph. One of the biggest is the knowledge about the world. You know, the acronym we're using is Satori Knowledge Graph, and we, of course, we crawl the web and we get all the informations. We do all kinds of processes. We're targeting people, places, organization, things. Things can be anything. Can be a song, can be an album, can be a movie, can be a sports team, etc. And what actions you take related to those entities. And this is in production, supporting Bing Search, supporting multiple Microsoft other products like Word, PowerPoint, Excel, those kind of things. Next. So we also have another one we call the academic graph, which is we actually tracked all the publications in the history and millions of authors and articles and how they are related, what are the field of study and what are the organizations and conferences, journals, etc. And third one is about work, is a work graph. So we have a huge office database, right? So we have people have activities related to their work, email, calendar, messagings, etc., and documents, and the SharePoint, the documents, etc. So that is a third large knowledge graph. And so what do? We support, as I mentioned, we support search, and we support from search all the way to Q&A, to enrichment, enrich your document work and recommendations, for all kinds of recommendation, advertisement, etc., and the relatedness. If you search something, what is the most related entities to this one, and the conversations. So that's the scope of our impact. And I'll just show a couple examples. For example, you ask a specific question, we give you answers rather than give you 10 blue links. This is from Bing Search, as you can tell. And next, example is conversations. Nowadays, conversation become, bot become very interesting topic, not only from consumer point of view, but also for multiple industries, enterprise, all providing service bot and QA bot, etc. But however, in our point of view, if you don't have a good knowledge base, knowledge graph in the background, your bot can do very little. You can only do scripted question answers. You cannot do deeper inferencing, deeper knowledge search. So that's why knowledge graph is important. So how do we do it? Of course, we're facing the same thing with same as every one of you. We're facing the raw data, structured and unstructured. And what we do is, everything we do is in the middle, knowledge creation. Since it's a large billion, hundreds of billions of documents being processed every day. So it's a huge combination of science and engineer work. So we have hundreds of people working on the behind the scene and do all the extraction, do all the inferencing, do all the conflation, and of course update. Things are not static. So we have to really implementing the real-time updates. When the world has anything changed, we have to capture those changes in different service tiers. Some is in the second, some in minutes, some in hours, and some in days. That kind of change. Of course, at the top of the pyramid is our product, which is high quality and semantically organized knowledge. That's all our dream, same as you. But we actually made it into production system. Next. So just to show, if you want to build a knowledge graph, I heard in today's conference that everybody tried different technologies, But to make all things work together as a real-time large system, in my point of view, we're facing three angles of challenges. They all, to me, is all orthogonal. If you want to build a small system, small coverage, it's easy, doable, but it's large. But when it's large, you still have to keep everything is accurate. You cannot have false facts or false updates into your search engine or into your PowerPoint, etc. So correctness is also, it's hard when it's big, because when it's small, you can verify, you can cross-validation, etc. But you're talking about billions, hundreds of billions of facts. That's very hard. And freshness, same thing. Everything has to be reflected, the change of the world. And this example just show you, one element of challenge. So Will Smith, nobody really realized in Wikipedia alone there are 200 Will Smiths, and any facts change, you have to make sure it's not. It has to be the same, the right Will Smith. And the most popular one alone, we have sources from 40 websites, and we actually have 100,000 facts about this entity, one entity alone. So that is the sort of scale of problem we are facing and the challenges we are facing. How many minutes? Okay, that's fine. So I was just talking, so I give example for how do we manufacture the word knowledge from the internet. But if you are talking about enterprise internal knowledge, there will be another angle of challenges. I'll just show the challenge. Maybe skip this one. Yeah, go to next one. Yeah, just enterprises internally, they have tons of documents. They have people. They have projects. People have different skills and different people working on different projects. All this never is really organized in a knowledge graph situation. But that's something that we hear again and again from enterprises. But that is actually giving a lot more new challenges, because unless your tool is 100% automated, scientists like us cannot have our eyes on any enterprise data. So that is a new type of challenges that when we work on enterprise internal documents. So I can stop here.
Can you guys hear me? Okay, there we go. Hi, I work at Facebook. We specifically work on the knowledge graph at Facebook, so I just spend 5 minutes talking about what it is that we're building. First slide. So first, why? I think a lot of people would ask, why is Facebook getting the business of knowledge graph? And actually, earlier this morning, we were debating a little bit on what is a knowledge graph. So depending on how you define the knowledge graph, many would argue we already had the world's largest knowledge graph. We had, the social graph. There's about 2 billion people on it. There's attributes about the people and relationships between them and so on. But what we found was we didn't really know a lot about the things that people were caring about, right? So on Facebook, say you checked in at a restaurant. So we know the fact that the restaurant exists, that you exist, and that you checked in the restaurant at the time. But we didn't know a lot about the restaurant itself, what kinds of cuisines it has or what was its opening hours and things like that. So this effort was started about a year ago to fill that gap and basically start expanding Facebook's knowledge of things in the world to complement the social graph that we already had. And really, so when we think about what we want to put in our knowledge graph, they have to be socially relevant in some way. Next slide. So that comes to what we put in it. So we generally have like 3 different types of things we put in a knowledge graph. There's the entities, concepts, and the actual words. One way to think about it is, the proper nouns, the common nouns, and then the words are the lexical, like surface forms of what people use in some particular language. Because the other challenge with a company like Facebook, we are international, so we have to think about not just English, but all the different languages in the world. So initially we started off with just analyzing data about what are people talking about. It's actually funny, like most people are not as intellectual as you would think. You can basically imagine what are the common topics that people are talking about with each other on Messenger, or what are they posting about on Facebook. They generally kind of fall in these categories. People is of course the number one thing that people talk about. People are celebrities in particular, but also a lot of places, points of interest. So these are like restaurants, parks, museums. And then media is a huge vertical, movies, music, TV. And then the last one is sports, which we haven't quite started, but we know that's coming up on the horizon. But the first three are actively in our knowledge graph right now. So how large it is? Probably compared to our other guests here, we're probably on the smaller side, again, because as Facebook, the company's mission is, unlike our friends at Google, whose explicit mandate is to organize the world's information, our mission is to connect people. And so we want to build a knowledge graph that kind of helps further that mission. And so it is small in comparison, but deep on at least the socially relevant entities. So we have about, so it took us about a year to get here, but we have about 50 million entities in the graph and about 500 million assertions about those entities. So these are facts. And about hundreds of types. So these are either entity types or relation types. So just to give you a rough order of magnitude. And we are focused on US only, although multilingual to start with, but I could imagine going outside the US will probably increase the size dramatically. So just an example, I think this is not going to be news to anybody in this room, but generally this is the kind of thing we put in our knowledge graph, right? So let's say, we know about the Waffle House. There's typically a Facebook page for most entities because some of the owners of the pages would like to, retain what their presence on Facebook is, and like us on Facebook or check in or things like that. And that actually, we'll maybe talk a little bit later on the panel about challenges, right? Where you have the conflict between the people that own the business versus what the customers want to see can often be quite challenging, at least for Facebook. So we have the facts, right? We have, the cafe and restaurant, the neighborhood that it's in, the city that it's in, the street, maybe the review from TripAdvisor, and so on. So that's generally what I think most of our knowledge graphs probably look like. So now let's get to, well, what do we do with it? So the number one reason to build a knowledge graph is to actually enhance the product experiences across Facebook. So this is an example in Messenger where we have, smart replies that are powered in part by the knowledge graph. Entity detection is powered fully by the knowledge graph. So, we detect you're talking about a particular song or about a place so that we can actually help you get something done. And so in this case, you're talking about a song and you want to send a link for the song to Spotify right there in Messenger. Maybe you want to save it for later. Maybe you want to say, I really like this playlist or things like that. Next slide. Yeah, and this is just more of that, smart. This one might surprise you, but stickers, which is our most frequently used feature, are also quite enhanced by knowledge graph. If you actually tag stickers with metadata about the emotion that they're trying to convey, or going back to the concepts part of what I was talking about, not just entities, it's also about all the common nouns in the world, and they really help us customize and personalize the sticker suggestions and so on. So yeah, that's Facebook knowledge graph in a nutshell.
Hi, so I work in the structured data team in eBay, and we are building a product knowledge graph. And by that I mean it's more than just a product catalog. We want to pull in all the sort of supporting knowledge we have for products, including relationships and variations in products, and linking that to external knowledge that we pull in from external knowledge graphs. Next slide. So why are we doing this? Today, eBay is a listing site. Sellers come on, they list their products. We have a team of taxonomists that build the category tree that you see on the left-hand side. And we take the listings, we classify them to the categories, and then we index that and surface it to the users. But that has a number of problems. I mean, if you go to eBay today and you search for a product, you probably get a page of listings for the identical product, all duplicate listings, because they're coming from different sellers, different variations, and different options. Next slide. So eBay is moving to this kind of model where we actually show product pages. And this, you search for an Nest thermostat today in the US, you'll get a product page, and we can show the variations of options we have that the buyer might be interested in. So they could be manufacturer variations that are fairly typical, given that type of product. But it can also be the deals that various sellers are providing. They can be the condition, given it's eBay, and various other options that we might want to surface to the buyer. And to make this transition from where we've been historically, from listings and categories to the product world, then we need this external knowledge of what these products are that people are selling. So I put a few examples in of something that's more knowledge graph relevant, I guess. So memorabilia and collectibles is fairly large segments for eBay. You take a shirt, that's a product. It's signed by Michael Jordan. That's a very different product. So we want to understand who Michael Jordan is, what sports he plays, what teams he's played for, link that to other products and memorabilia that might be interesting to that buyer. On the collectibles side, we could have a postcard in Paris, 1940. So we want to also know that that's a French postcard, it's a European postcard. It's 1940, so it's also a wartime postcard. And that kind of external knowledge that's typical for knowledge graphs actually defines the product and its value and interest to the buyer. Yeah. So what are we doing? So we've been working on this for under a year. We are building the graph. As I said, it has a lot more than just products in it. So in terms of supporting information, we have value types in there. We have fitment and relationships, the standards of things like connection standards, HDMI and USB, understanding how those relate to the products. Variations is a large part of what we do and what we want to surface to the buyer. And then from external graphs, we pull in the standard knowledge graph material of people, places, brands and companies. So what our system looks like at the moment, we have a statistical data mining system that's been in eBay for a number of years. It's very well tuned to our listings. It runs at huge scale. It runs over billions of listings. And it surfaces and extracts potential entities, products, attributes, and values that it finds. But at this point, there's still strings. It has no understanding of what they are and whether they're valid or not. We also pull in buyer and seller information. Like queries, clicks, and conversions are fantastic for actually defining structure, what people are looking for and what they end up buying. It helps us define the class hierarchies and the relationships and variations that are important to buyers. We do a lot of work on knowledge matching and verification. So this is taking potential products. They could have conflicting information. They could have missing information. There could be variations. There could be second-hand versus new. Matching that against our knowledge graph and verifying. And by verifying, I mean we could use things like RDFS, domain and range to actually help us check types. So if you have an attribute that's width, then the value better be of type dimension. And we use the RDFS to help us do that. Graph stats. So we're currently in process of building this, so our numbers are changing daily, but we expect to get to the order of a few 100 million products, which is what we expect we have today. And there's probably a few billion triples about those products, not excluding the external knowledge graphs we pull in. And our main problems are probably unsurprising. Identity is number one thing we spend time on. Are these two product descriptions the same? Are these two listings the same? Are these two strings the same value? And another aspect of identity that we look at is in relation to variations as well. But identity depends on who's asking. So if you're talking to the seller, he needs to be precise on what he's selling. And whereas if you ask the buyer, maybe all red T-shirts are the same product to the buyer. So you want different definitions of identity. And a graph is the perfect data structure to have these multiple views into your product graph. And yeah.
Perfect. Hi, Jamie Taylor. I work on Knowledge Graph Schema Team. Several of my colleagues are here in the audience, so you have plenty of people to talk to afterwards. Knowledge Graph at Google is about 1 billion things, and we have about 70 billion facts about those things. And that's a lot, but it's not nearly enough. We get about 15% of our queries every day are things that we don't know anything about, that we have never seen before. While this is big, it's not nearly big enough. And so it's a challenge to work at this scale, and I think it's going to be even a bigger challenge to operate at the scale that's going to be necessary to do the things that we really want to do. So what does Google use its knowledge graph for? This was actually sort of the blog announcement for when we launched Knowledge Graph, and it hasn't changed, which is, if you're going to organize the world's information and make it useful, which is the core mission, then you really have to be operating semantically on the things themselves. You can't be sort of viewing these things just as sort of ephemera of language. And so making that transition into a world of universals is extraordinarily challenging, and that's sort of the space that we operate in. So, tonight we're going to go and see ocean sunfish, and if you type in sunfish, it's good to know that there are multiple ways to view sunfish. In fact, there are multiple animals that are identified colloquially as sunfish. And so being able to differentiate these things and actually say, I know specifically which thing you're talking about, and the different sort of assertions that are associated with that and how they're related to one another is incredibly important. It's a little disappointing to confuse an ocean sunfish with the sailboat sunfish. But I think one of the fun things to notice is, we highlight a couple of things here. We actually understand, the family that the ocean sunfish is a part of. We also understand different parts of the sailboat. So if we actually sort of go to the next slide and look at what's there, we understand that, lateen is actually a form of sailboat rig, and that daggerboard is actually a part of a sailboat as well. And so, being able to sort of have these sort of deep relationships in the knowledge graph is sort of a core part of our ability to use it to understand queries and understand what's going on the web. So, what do we have in it? Well, I think everybody has probably experienced the knowledge graph panel, which is the most sort of clear user-facing surfacing of the knowledge graph. So we have, an incredibly wide range of things in there, and it's almost, in some sense, nothing is off limits. Obviously we have the people and the places. We understand what those people and what those places, are related to, and how they're related to them. I think that's a very critical part. These aren't just sort of unnamed links. We actually understand what the semantics of those links are. We understand, that there are other universals out there like currencies and things like that, and we understand sort of what they're used for and under which conditions those items would actually be utilized. So next. So challenges. I think this is where you can have a lot of fun talking with the folks that work on Knowledge Graph that are floating around the conference about sort of all the various problems that they have and places that we would love to have help. Personally, I have many challenges in sort of working with Knowledge Graph. So one is that the Google Knowledge Graph has been a really sort of enduring proposition. I've been working on this for more than a decade. And when you have a system like that and you have a data set that has persisted for that long, its evolution itself becomes sort of something that's really interesting and complicated to manage. The second part is that it is way bigger than my brain. I cannot keep track of all of the parts of Knowledge Graph. And so if you're working on systems where you can sort of keep everything sort of, in your head at one time, I don't think you're operating at the scale at which many of the knowledge graphs for the people on this panel are operating. And at that point, then institutionalized knowledge and tools and things like that become incredibly important because you just literally can't sort of keep up with it. The other part is there's an organizational complexity to this, which is really just, it's hard to explain. And that is that there are so many users of Knowledge Graph around Google, and there are so many stakeholders, there are so many different data sets that are coming in. They all have different demands, they all have different views, and actually sort of managing through that process itself is actually a huge challenge in making a system that works. I have to say, these are actually terrific problems to have, and I encourage you all to have them. So the only survival mechanism that I know of is actually to take a very principled approach to this. So one of the biggest challenges I think that we have with building the knowledge graph at Google is managing identity. And I just picked up a couple of random examples here. So, is the Santos Football Club the same as it was before Pele came and played with them? Is it the same after he left? This is really sort of a crazy identity question. Teams move around. Michael Jordan and the Chicago Bulls is another favorite example. It seemed like a really different team after he left. Sailing, well, there's sailing the sport, and there's sailing sort of the means of transportation. There's sailing as a recreational activity. Are these all the same thing? And it's really easy to say, oh, no, you should really split these things up after you've realized that you conflated them to start with. But the question then is sort of like, it's really easy after the fact to say that, then how do you actually manage that transition? So these questions of identity are really core. Cuba, the island, the country, the government, unbelievably hard to actually get right the first time. And then sort of along the lines of managing identity is maintaining semantic stability. So great, once you actually have this notion of strong identity and you're trying to manage it, then you have to manage it over time. And I have to say that itself is also a problem because you think you got it right to start with, and then you say, is e-sport really a sport? I don't know. It wasn't around when we actually came up with our definition of sport, and we didn't even intuit that something like this would be coming along. Movies and television. It seemed so obvious 10 years ago when we were working on Freebase that movies and television were really different things, and now it is incredibly confusing. Broadcast, podcasts, and streaming, another place where we thought that it was really easy to draw the line. Not so much. And I think it's a really interesting challenge to manage these things over time so that your existing systems, which are making semantic inferences, continue to do the right thing, even though you need to evolve them forward. And that kind of scale of engineering is, I think, the biggest challenge.
Thank you. Let me first start out by saying, Yuching, the slip of tongue you had, I wish it was true. Everybody who knows your contributions to IBM wishes that was true. The knowledge graph at IBM Watson, you can go ahead. Just a small context of where does knowledge graph reside today, or what I'm talking about. We had a lot of things that came together to create what is today called Watson Discovery. The original Watson Jeopardy system, which was a fact-based QN, Wikipedia, and many other sources, came together with other technologies we were building at IBM Research, which were around figuring out insights from patents, and then there was stuff around figuring out insights from medical abstracts, very scientific projects. They all came together to build this product called Watson Discovery Advisor. I came from the patent mining side of the world. Yuching actually was working on the Jeopardy side. And then all of that became Watson Discovery Advisor, which was our flagship product when Watson came out. And then now it's transforming into a Watson Discovery Cloud service. Moving on, what I want to say the underpinnings of our notion of knowledge graph is to help do discovery. And I won't spend a lot of time on this slide, but talk about the fact that discovery is about finding the non-obvious things, things which do not exist even in documents, hitherto unknown knowledge. So you don't expect the knowledge graph to tell you this is a new thing. It is a process in which your knowledge graph should help find from that process these answers. What kind of answers? A hard problem is finding new link between existing entities. The hardest problem is finding completely new entities. And a more typical problem which happens on a regular basis is to find changing significance of links between existing entities. If you abstract it out, this is what the entity relationship definition is. In a nutshell, we don't have a knowledge graph at IBM Watson. What we ended up targeting was to build a framework which will allow just about anybody to build their domain-specific knowledge graphs. Given our enterprise client base, we had a lot of people who wanted to build knowledge graphs out of their own personal scientific literature, out of domain-specific documents like oil and natural gas, like life sciences, etc. So that's what we ended up building, a framework which will allow anybody to start with unstructured text, a little bit of known knowledge, and put that together in a seamless way. And believe me, even though the scale is not as huge as the global knowledge graphs, the fact that you have to give out a piece of code for somebody else to build a knowledge graph themselves and not in-house is a hard problem in itself. We offer it as a part of our discovery service. The key enterprise sectors which we deal with start from banking and finance, services, to very investigative scenarios like cybersecurity, scientific discovery, life sciences. We have clients in defense, exploration who use that. There are some scales which we talk about which our customers have reached by taking our technology and building their own knowledge graph. If we move on to the next slides. Now I want to get to what we learned while we were doing this, is sharing it back with the community. There is few bullets here. I will probably spend time on a couple of bullets which are closest to my heart. Polymorphic store. I have had a long fight in IBM trying to talk to people about their biases of one graph versus using this database versus using this technology. In the end, the realization is very simple. It is a polymorphic solution. There are many workloads which a knowledge graph has to serve, and do not debate about one technology which will solve it all. Think about a polymorphic approach which can be then maintained consistently in different stores, the same knowledge redundantly even. One other piece I will talk about is every new piece of knowledge, knowing its cascade effect. So when you start building these knowledge graphs with polymorphic storage abstractions, there is an original piece of information which then gets shredded into multiple stores. What happens when that information changes? How do you pass that along to different pieces of stores is a hard problem. These cascade effects being managed, just like you think about cascade in database SQL, now you're thinking it across multiple stores. That's a hard problem. We learned that is an important problem to solve. I will not talk to the rest of them. You can go find out more details of this from some detailed talks I have on that link there, talks.anshu. If you move on to the last slide, the big open problems that haunt us. One of the biggest problems, which I don't see a lot of people who are building knowledge graphs at least talk about openly, is that one of the principal premise of knowledge graphs is to track change. So it's not just about modeling a knowledge graph, it's about modeling what is changing in the knowledge graph, quantities, and how changing in one quantity affects something else. Right? Let's start modeling that as first principles in OWL or somewhere else so that we can start doing that more formally. And then one more thing I'll talk about is merging relationships discovered. Again, since we were dealing with unstructured data from enterprises, their documents, and structured data, which is known knowledge, it always became a hard problem to say, how can we merge the information which came from those discovered documents, which has its own notions of TF-IDF kind of mutual information scores, with a known knowledge which just has one record, right? Merging these two pieces of information and ranking them seamlessly is a hard problem, which I'll, again, give back to the research community to help us solve. And that's about it. There are other problems listed here which you could go through in detail. Thank you.
Thank you. So thank you for this wonderful description. I think I've learned more about all these knowledge graphs in this, 25 minutes that we could have in any other circumstances. So microphones are, there's one microphone here in the middle. I think that's probably the best place to ask questions. I'll start. So I know you were all listening carefully to each other. So in one word or one sentence, what do you think makes either the challenges or the graph itself in your specific setting different from all the others? Or what's sort of unique about it? If you don't, I will have to answer, but I would love to hear from all of you. There's a long line. And we will go over time by 5 or 10 minutes. I know we started late, and buses are right here, so it's not going to take you that long to get there.
So I'll start. The biggest challenge Facebook has is maintaining or managing the conflict of interest. Like I mentioned, a lot of business owners own Facebook pages, and they want to represent their business to the world. And actually, a very concrete example is a very famous ramen restaurant in New York. And we met the owner, a very nice, elderly Japanese gentleman, and he insists that ramen is fast food, which it is in Japan. But in the US, when people search for fast food and they go to this very swanky upscale restaurant, they're kind of like, well, this is not what I asked for. So having that conflict of interest. Another example is when a movie franchise wants to consolidate, one Facebook page for all the Star Wars movies, right? Because they want to keep the fan count, they want to make the marketing and all of that work. But of course, a lot of people in the audience will argue about which is the best Star Wars movie. Like, not all the movies in the Star Wars franchise are equal. They each have their own ratings. And so managing that has been a kind of a challenge unique to Facebook. And another one I'll mention is it's probably similar to what Jamie alluded to, is just maintaining sensitivity. I think the answers to questions depend a lot on who's asking. Even if you take a very simple like knowledge graph problem like modeling countries in the world, there's 195 or how many? It really depends. Is it designated by the US government? And again, as Facebook, because we're an international company, we have to be sensitive to local sensitivities, India-Pakistan conflict or Israel and things like that. So depending on, we need to be able to build a system that has the ability to put all this nuance into it and put policy around it so that we're not offending people. Yeah, I would say those are top two challenges on our mind.
Anybody else?
Yeah, I mean, I would say, like, one of the things at eBay with the product graph is what I mentioned on identity. I mean, identity is quite flexible for depending on who's asking and what you want to surface to the buyer. And so the structure of the knowledge is very multifaceted, I guess. And, that's unlike, say, an ontology of people or places, or that's fairly fixed. And so it is much more of a graph in the sense of we have multiple trees and multiple views and multiple ways of looking at the same product data. That's quite a challenge.
One thing that I didn't mention is managing consistency. And I think that is truly one of the most challenging things that we have. Because we need to communicate sort of the semantic descriptions to both machines and to people. And keeping those sort of in a state where new data is being added and data is being sort of moved around, and we're maintaining that semantic consistency, I don't feel like I have sort of all of the tools necessary to do that semantic description, to keep that consistency at the scale that we need.
In the world of giving enterprises something to build their knowledge graphs, one of the biggest challenges we face is this federation across the notion of a global knowledge graph, which might be like Google's knowledge graph or one public knowledge graph, with what we call a domain-specific knowledge graph, which is specifically built for life sciences. Let's say it doesn't talk about celebrities, it talks more about drugs. And then a customer-specific graph, which is populated with their own personal proprietary stuff. To federate across these three systems and be a seamless answer, rank them across these three systems, is a hard challenge which we continue to face.
So I think the challenge is all about the same. It's about the semantic description, how granular you want to be, and how fast you can catch up the change of the word. That is two particular area we found. You want to go very specific, but it can be very lengthy, and you want to be really catching the change, because a lot of things are really it's evolving. And not only like esports, same thing, we've been thinking about that too, streaming video, what is it, right? That kind of thing. So it's evolving, it's fast changing, how fast you can catch up the change. And that's from semantic description point of view, but also from, we have to dealing with a large system and engineering systems. The system has captured the change. That is also adding to the challenge from maintaining and produce the system. Another thing I found is when you serve internet consumer, either in the messaging or the search engine, people's interest is also evolving. And same entity paying 5 years ago, now people have found, okay, that's nothing interesting, right? So you have to find what are the latest, most interesting things to show in the limited space. That's also, another angle.
Okay, great panel. two questions. One more like about sharing and business models, and another one technical. My name is Atanas Kyriakou from OnToTech. So the business question is, do you plan and who plans to share these big knowledge graphs? So which of your companies have the plan to share this and make it available to the people in this community or to others who may want to exploit these gigantic knowledge structures for other purposes? If yes, via what services? So obviously you're not going to provide a dump. So it's probably going to be data as a service, graph as a service, or specific services like similarity or profiles, God knows what. The second question is, well, because that's a semantic web conference, in how many of your projects you have RDF or Sparkle somehow involved?
Okay, I'll go first. So on the open data question, it's a very good question. So Facebook already has a graph API that you can access for public data that is designated public by the creator of the data, either through the Pages API. But there's also another effort for us to contribute facts back, and we'd rather piggyback on the existing efforts rather than create a whole new one of our own. So we'd love to work closely with Wikidata, for example, and start contributing facts back that are public and that we are okay to share, just to answer the first question. And I don't know if anyone else.
Yeah, I'm obviously a huge proponent of open data coming from the free-based world, and I think things like schema.org and Wikidata, which we've been contributing back to, are really sort of the way forward for this story. And so I think the more we invest in Wikidata, the better this community is overall.
Okay, but Wikidata is just a fraction of what you're doing, right?
What was that?
Wikidata is way smaller and different than your knowledge graph. So the question is your knowledge graph going to be somehow available? I mean, we got all this great work on embeddings that is all citing Freebase, right? So, yes.
So giving back to the community is actually a very tricky effort, and Denny and I actually believe. Can't think of his name right now, giving back the Freebase data into into Wikidata was an effort that we undertook, and it's actually very hard, and so mostly because for a lot of those things, there's a lot of pieces that the Wikidata community requires, which I think are absolutely the right things, which we could not fulfill, and so that giving back is actually a very sort of big effort and quite a challenge. And so we're interested in being able to help with this, but it is actually a bunch of work and it's very tricky.
Yeah, but my question is actually not about contributing them back and making it available to everyone for free, more like probably offering paid services, APIs, the way you have many other APIs in your cloud platforms.
So, anybody else wants to add something? No? So there was a specific question. Anybody think who is using RDF or RDFS or OWL directly? I know sort of, again, a lot of the same ideas are in those knowledge graphs.
Partially.
There we go. It's actually more than I think anybody here expected, so. Next question.
Jamie Taylor mentioned the issue of metonymy, specifically with reference to Cuba. Is it a country? Is it an island? Is it a government? It's one that I would venture to guess most of us wrestle with from time to time. I wrestle with it every other day. Not to stray into proprietary territory, but I'd really be interested in the takes all of you have on how to grapple with that one.
So I'll start with the fact that I have to say when you actually cast it as metonymy, I, for one, seriously underestimated this problem. And I think the part of it is that I recognized from a pure sort of knowledge modeling perspective these things were separated. But how intertwined language and colloquial sort of thought is about these things, I think is one of the biggest challenges that we continually have to sort of work through on a daily basis. And I have to say that, I know language binding to knowledge is sort of a hot topic, but I think there are so many subtleties, especially in sort of the colloquial usages and the common noun space. And I have to say that this is one of those places where I seriously had not a big enough sort of viewpoint. And I think that we as a community are going to have to do a lot more work in this.
Anybody else?
If I interpreted your question correctly, a point, I think one of the big ahas for us, we have this debate about entity resolution, when to resolve an entity. And working through one of the researchers I was working with, one big aha was that let's push the entity resolution to the runtime in context of when somebody is trying to use that entity. And I think to me that is one of the biggest things we could do. It's not always possible depending on the application, but if you could do that, then the colloquialism would help you figure out whether people were referring to Cuba the country or Cuba the government or whatever. And so in certain scenarios, just push the entity resolution. Don't make a decision in advance. Let it be the last mile thing.
So maintain the 3 separate entities, but interpret when the user query comes in.
Yes.
Okay.
Yes.
Any? All right.
I was going to say the same exact thing. So.
We have a long line, so we don't need to keep on one question.
Hi. So I want to ask a question which kind of we are coming from the left and from the right. So Anshu Jain mentioned that there is no single solution, there is multitude of solutions, and then we asked whether you use triples. So let's put it that way. What kind of technologies do you use? Are those graph databases, relational databases, triple stores?
Sure. So as I said, we use multiple solutions under the hood. We have not invented any of our core storage technology from scratch. We are using databases. We are using indexes, text indices to store text. We are in fact reverse indexing graphs into text indices to query them intelligently. We are using in-memory data structures. We have evaluated graph data structures for certain dynamic incremental ingestion requirements. We haven't found them to be easy to dynamically update, but we are consistently looking at building a fundamental graph data structure also into this thing. But we'll move it as an add-on to existing data structures. So database, indexes, in-memory data structures, and lastly, graph data structure is what we aspire to add.
Yeah, I'd like to add to that in terms of flexibility. So we have built an architecture that allows us to use different technologies for exactly the same reasons. We have a front-end replicated log, and then any storage technology can just tail that log and get the facts come off. So we can partition data differently, we can index it differently, and we can query it differently, and we can use different technologies for different levels of service. And so it's more of an architecture of using various components together. And for us, that makes the most sense.
Go ahead. If I could make one plea to the community, there is a huge gap in the open source world, and we are happy to sort of participate in this discussion of something which is built on top of some streaming technologies like Kafka, etc., which can seamlessly populate multiple stores and make it a pluggable architecture so that you can add new stores, and it takes care of consistently maintaining change across these stores. So it's a big space which needs to be solved.
So I want to talk about, you're asking about systems. It's more like an engineering issue. So in our words, we have production, the back-end production system, as well as the online serving system, which are different, separate. And in terms of serving, for example, Graph Store, and there are a lot of open source Graph Store, but how many of them I really can use in our world, it's very limited, based on the size and based on the QPS you can serve, as well as the the rate of updates. It's a very challenging problem. So we have a back-end streaming system as well as a batch system. So streaming to capture really the faster changing trees and directly sending to the front end for the serving. So it is not solve the problem on neither scientific point of view or engineering point of view. We have mixed of at least a half dozen systems.
Next question.
Thank you. Thank you. This is just following from the previous question about the uses of semantic web technologies in your infrastructure. Basically, how old too have you built ontologies and run reasoning? I don't know, and how is basically you have built this and incorporated in your infrastructure. OWL to ontologies.
OWL is on top of our minds. We have not integrated it to the discovery service yet, but we have natural language service, interpretation services, which depend heavily on OWL-based ontologies. In fact, if you speak to, I don't know if Alfio is still in the room, Alfio from IBM Research is leading large initiatives to bring the entire world of RDF, OWL, into our main product line. So you should see much more action in that space from us very soon, and try to find Alfio today or me, and we can talk about it more.
What about reasoning in general, not necessarily OWL or DL reasoning? Is there any reasoning happening to verify your knowledge graphs or to build them? Any of you, anyone who wants
on that question, reasoning is one of the biggest drivers of why we want to bring OWL. Right now, our graphs don't reason well, or our notions of knowledge graphs. So that is the driver of bringing in OWL and other semantic technologies.
Yeah, in terms of our work, we don't do incredibly complex reasoning. We use it for path traversal and inference. Some of the reasonings that we do use is for type checking and verification of data. So as we've got raw and structured data come in as strings, we're verifying these values and checking that it makes sense given the graph, and those are fairly simple reasoning.
I just want to add, we don't use technologies like OWL, but again, reasoning is one of the core parts of what we do in building the knowledge graph. That's actually the step, at least the Facebook knowledge graph, where most of the value is created. The knowledge graph ends up being greater than sum of its parts because a very concrete example, we learned from Yelp that a particular Starbucks has Wi-Fi, and we learned from Foursquare that people find it to be a generally quiet place, and then we're able to reason that it's a good place to go for work. So if somebody asked a question like, I need a coffee shop for working. So that type of reasoning, but we have a custom proprietary system that kind of applies that at scale across many, many different, and of course we consume data from all of the open formats, but the reasoning logic itself is custom. Yeah,
yeah, same here at Microsoft. The reasoning is used a lot of places. And first is inconsistency checking and the fact validation. We're not particularly talking about OWL, but we're using a lot of the machine learning and to derive new facts and cross-checking the accuracy of the facts.
Thank you. Next question.
So as a long-time AI researcher, I really appreciate all of the challenges that you're facing, and I am extremely excited that you're facing them from a very practical perspective. And my question is that I see the five of you, and it's giving me flashbacks to a meeting that I attended 10 years ago in the Apache Software Foundation. So it was your colleagues talking about their software and how they build on the Apache Software Foundation open software ecosystem, so that it's not the case that every company develops their own Tomcat software, but everybody uses the same. Their developers are contributing to the same software base. The software is better quality because there's so many people making sure that it works well, and so that the business proposition is on the services that you build on top of that common Apache software base. I thought it was a very powerful panel at the time, and so now that I see you here, my question to you is, do you think that it might be possible, or maybe my question is, how long is it going to be before we have maybe a Comanche knowledge foundation instead of an Apache software foundation? So a Comanche software foundation, sorry, a Comanche knowledge foundation where all of you find a way to involve the community in an open forum where, you know, we don't have different, you know, proprietary systems all learning about Michael Jordan, but we have, you know, software and content that is curated and contributed in this open ecosystem.
And before I give you the floor to answer, I know that there will be buzzes, so I think that will have to be the final question. I know you guys have been lining up, but I think people need to have a chance to run to their rooms.
So it's such an interesting sort of way to sort of lay the story out. I have for years tried to tell the story about core versus context. And context knowledge in so many areas is, you know, people and locations and companies, the standard things that like NERs, you know, are picking up. And I think what's really interesting when you look at most graph systems that I have had the chance to analyze is that almost everything connects to sort of like that kind of a core foundation. And I'm sure that we have a lot of replicated assertions about those things across all of our data systems. And so I think, you know, this is where Wikidata, this is where schema.org really has this opportunity to sort of like be that foundation, because frankly, I think, you know, all of our systems, and this is really what I think Natasha was hoping to get from this, they're really diversified, right? And I have to say that, you know, even there are parts of our ontology and our data which are crazy specialized and in ways that are optimized for very specific things. And that kind of like core, that's our value proposition. But there's so much context data that I would really like to see sort of out there and curated by a much larger community that's actually invested in it. I think that's terrific.
I just had one comment there, just to add a challenge. We're definitely thinking about this, and again, there's a separation between sharing data and sharing the actual software. The data, again, as mentioned before, Wikidata is the way to go. Like, we got to have a central corpus where we keep adding facts, and we're definitely supportive of that and intend to do it going forward. On the software side, just one of the challenges has been basically translating the scale of a company like Facebook or Google in a way that's actually usable by researchers. If we just did that today, it would pretty much be unusable because you don't have a million machines, right? Although that is changing now with AWS and Google Cloud and just availability of cheap compute. So it is narrowing the gap, but it is still a hurdle that we have to overcome to actually make our software be usable in a way outside of you know, these large data centers that our companies run.
Thank you. So I think, you know, based on the applause, I would say that since you have resources that dwarf what we can as individuals contribute in the Wikidata sphere, maybe you can consider that.
So that's going one way, and so I will use my prerogative as a moderator to ask one final question. Raphael told me he's not going to kill me for that, so I'm going to do that. This is a research community who probably knows semantic web and knowledge graphs better than anybody. What are your research challenges that they should be thinking about? Quick, but briefly, because he will kill me if you go on for too long. Not you, but me.
So I have a very quick one. We had actually a great keynote this morning about privacy. I think that's a very interesting challenge. We care a lot about privacy. A lot of our features are focused on providing value to the user, and one of the biggest challenges we have is that these knowledge graphs are so big, right? They're a billion assertions, hundreds of millions of entities. We can't pack this into the phone. And so if there's a way that we could provide the same functionality as we did today, but without having to run all the software on our server side, which requires that all the messages be sent to the server, I think that could be incredibly interesting. And I think it's technically very challenging, but also we haven't even scratched the surface on how do we, you know, contextualize or personalize the knowledge graph for the individual, send it down to the client, have all the reasoning and all of the inferences happen there on device learning and so on. I think that's definitely a big area that is of interest to us. Yeah.
I'll repeat, federating across one big, large knowledge graph with very much noise a largish graph which is relevant to the domain, more context, and a very small graph which is even more contextual, and getting a right answer which is not just a single answer, ranking across these three, federating. That's a big problem.
So I think, I actually prepared a whole page of challenges for this community, but she said only one, okay. So in my view, I've seen people do a lot of entity recognition and linking, etc. One talking about NEEL this afternoon. So this is all interesting. But in my point of view, using machine learning, using all the inferencing approach, including embedding, etc., can we get to, can we scan the news every day and identify new facts? In the precision, recall, in the very high precision recall, that is actually quite big gap. And we tried a lot of things, and I don't think anybody is there. You just scan the news, you just discover all the new facts, new things. That's really not easy.
So I guess I'm going to be quite techy here. I think like deep learning and machine learning are like hugely popular right now. I think knowledge graphs are perfectly positioned to support those technologies and make step changes in what they can do without using knowledge graphs. So if I was getting into research today, I'd be going straight into that area. And some ideas would be around, like a lot of these systems are trained on the frequency of occurrence of things, like embeddings are a prime example. And that's not the same as the meaning of things. They don't always represent concepts and spaces correctly. They represent frequency. And so I would be looking at areas like that where knowledge graphs and machine learning can work well together. And it's a prime place for knowledge graphs to make a big difference in that area as well.
If you are a part of the academic ecosystem, I would ask that you make sure that knowledge representation is a core part of the curriculum. Just as everybody has, some class that talks them through data structures, making sure that everybody that comes out of these programs has some experience with knowledge representation is absolutely critical right now in the industry. And so please, thank you.
I actually cannot agree more, because every new hire, every college hire we got, nobody knows about ontology.
I think this is a very good, we know what to do now, right? I would like to thank the panelists for a wonderful panel. Again, I've learned a lot. I hope you did as well. I think all of you coming to the aquarium, right? So you will find all of them there. Feel free to talk to them. Buses are outside. I think you have a couple of minutes to run to your room if you need to.
Everyone, please remember to bring your name badges, your registration name badges to the aquarium. They'll serve as your entry ticket. Please don't forget that. We can't let you into the aquarium without these. Thank you.